Hello, welcome. This is the first tutorial for Animaquina. In this case, I'm just going to do an overview of the software and what it's possible to do. Currently, the first thing that you want to make sure is to install Animaquina. Once you have it, you can check that in add-ons, and then Animaquina should be showing up here. Very important, you might get some warnings, that's fine for now. The first thing you might want to check is that your license includes your robot, first of all, and then depending on what you require, you might get access to different features inside Animaquina. The next thing is, depending on your robot, you might need to install some of the libraries that are required to run your robot. In this case, I already have installed most of these. Some of them are actually used for simulation. We're not going to be running in through those today. But in any case, if you're missing a library inside the debug dependencies, there should be an installer for the missing libraries that you might get. Now, the first thing I'm going to do is in the robot registry, you can see I already created some robots. So just put a name for a robot and then add the robot. This should add it to the registry. That means that you can have multiple robots in the scene. Now into the setup, the first thing is the robot type. Here you should be able to select the robot brand of the robot that you need. In my case, I'm going to pick a universal robot. And then the second thing is selecting in what collection that robot exists. As you can see, I have 4 collections here. Each one is for each one of the 4 robots that you see on the screen. In this case, the robot that I'm going to start with is the UR10E twin without the 001. So I'm going to pick that. And then I'm going to select what robot type this is, UR10, and I'm going to set the UR axis. Now, after that, you want to set your backend. There's 2 options, URX and URTD. These are 2 different Python libraries for controlling the universal robots. Depending on your robot, you might get a backend selection or not. In this case, we're going to go with URRTD just because it's more maintained than URX. They both work and they both have a similar functionality, but there's a couple extra features if we're using URRTD. Once we did that and we picked that backend, we can look into our robot and pick and set the IP address of that robot. So each robot is going to have its own IP address, and then we can connect. Now, Animaquina by default is going to first find the TCP position of the current set tool. So in this case, we can see that there's no toolset, so our TCP position is right in the middle of the flange. And also, Animaquina is reading in real time the position of the different axes of the robot, the different joints of the robot. So if you go and jog the robot now, actually on the actual pendant, you should be able to see the robot updating into the scene. A thing to take into consideration is that sometimes your robot, you want it to be right in the middle of the scene, in the 00, in the origin of the scene. But in my case, I have 4 robots, so I kind of set the origin right in between all of my other robots. If you want to move the robot's position to a different place than the origin, you can adjust that, or maybe you want to move it back into the origin. You can do that by selecting your base empty object, this one, and then here we go to item. Here you can set it to the position that you want. Now, in my case, I'm going to bring it back to that position I had previously shown you, which is 65,1.1 on the X and Y axis. And you can see that it automatically updated the TCP as I was doing that. All right, now very important is to make sure that you have a TCP and a target. So we have 3 main empties to think about. One is the base object, that is going to be the parent object for a robot, and it's going to allow us to position and orient the robot in the scene. We have the TCP object, And in this case, the TCP, you see, if I move the target object, which in this case is the target 2.001, if I move it, that's just the desired target, is where I'm going to move the robot next. But you can see that the TCP object it's always going to be in what we're reading from the actual physical robot. So now that I move the target and that I selected both my TCP and my target, I can collapse the connection and the setup windows here. And then I'm going to go into control. So the first one, sync from robot, all this is going to do is update the pose and the TCP position. But in our case, we already enabled real time. So we are reading this 25 at this speed rate at 25 times per second. Again, that's a feature that's a parameter that you can change. Now, the first thing that you can do is you can actually come and move the robot here, move to target, for example, and this should be able to move the robot in that position, right? So this allows you to pose the robot. As you can see, I can change the position, but I can also change the orientation. And again, if you want to give it absolute values, you can go into the item and then set the rotation, for example, 90, 0, 0, and then this should be, this should give us a perfect 90 degrees orientation. The next thing is we can go into teach mode, and then once you enable teach mode, you should be able to pose the robot manually. One interesting thing about the teach mode is that we can, for example, find some position in our scene and then digitize that position. For example, in this case, I can go there, I can add a marker, and you can see that Blender added a marker for us in that position. Now, make sure that you make these markers outside of the robot collection and you select that collection so that these are selectable. But what that does, that can give us a persistent, I'm going to move the robot back into, I'm going to disable teach mode and move the robot back to the target. But you can see that now we can digitize that position. This can be used to digitize multiple positions and, for example, map a work surface area or anything that you need. An obstacle. And again, if we want to go back to that exact same position, we can enable snap and then go to vertex, move that out there, and then move our robot to that position. And again, it's just a tool to be able to digitize physical positions into the robot. Now, if you want to run a toolpath, you can see here that we have two options. In this case, I'm going to add a new mesh, a circle, and then I'm going to bring that into reach to my robot, put it in something that looks comfortable. I'm going to disable snapping. That looks comfortable enough for me, so I'm going to now run a toolpath, and you can see that the robot is going to move from the current position. It's going to perform that toolpath, and then it should be able to go back to the start position that we were in. a couple of settings that we have there before we send that motion. We have motion settings here, and this can help us change the speed. For example, maybe we want to do this a little bit faster. We can change the speed, the acceleration, and maybe we can also change the radius. And in our case, for example, we can, in this case, I can put a little bit more forgiving radius, which is the radius is going to be the smoothing is going to be doing between points. So you can see now I should go there and then perform the more smooth movement in between these points. Now, what we're actually sending is the actual positions of the vertex data in a Blender object. So if you're curious to know what are those targets, you can go into the spreadsheet and look at the object that you're sending, and this is going to be the positions that we're going to be sending. What this means is that if you apply a modifier, for example, if you apply a modifier or a geometry nodes modifier, then you can compute those new positions and send them to this toolpath. Another way is you also have a run toolpath buffer. So in this case, I can send this, and you can see that that's a lot faster because it has its own data. So I'm going to change the speed a little bit here, because actually now we're sending joint positions. So let me change this to 0.2. Maybe I can leave that one there. Buffer should be a little bit slower. There you go. So now I can, as it's performing the points, we're actually buffering some points. So I'm going to send it one more time, and then I'm going to update the path as it's going. So you should see after the buffer has run, the robot will correct to that path. So again, that's an option that you have in case you want to add some activity to your toolpath. That is possible. Now, another thing that we can do is we can start puppet mode here. Then we can grab our target, and then as you can see, we get direct control of the robot from the Blender scene. An interesting thing about this is that, I'm going to stop open mode for a minute, is that we can use all of Blender's animation constraints to our advantage. So I can convert this to a curve, and then I can grab my target, and then I can add a constraint, follow path, and I can pick that target. Now if I animate that path, and then now that that's animated, we can see it if we change this to a time. If we change that to the time to the timeline, we can see that now we could stream that data to the robot. In a similar way that we did before, all I'm going to do is first, before I start the puppet mode, I'm going to move my robot to that position. And then I'm going to start puppet mode. And I'm going to animate this. So you can see that the robot is trying to catch up with the target. There's a little bit of a delay. But a cool thing about this is that we could loop this behavior and also update our toolpath in real time. So there's no buffering here. So do this with caution. And again, there's many more constraints that we could be using for that. Now, if you saw what happened right now, if I remove the constraints, so now we're not animating anymore our target, and we kind of lost our target. So when that happens, you can go into snap target to TCP, and that should have brought our target back into this position, and now we can move to target. A couple important safety features of puppet mode is that when you are in puppet mode and you make an abrupt movement, the robot should lose its tracking. If you come close enough, it should snap back into it, and then you should be able to move it. And again, if a movement is too far, you should lose that tracking, and that's for safety. That's just for safety. And in a similar way, we can actually rotate the robot in real time here. And that's puppet mode. When you're running toolpath and when you're run toolpath or this one, the run toolpath buffer, you can also configure what type, if it's a linear, a PTP, or and different parameters for the type of movement that you want to send. Now, this one, the home one, what it's going to do is going to send the robot to the home position, but I have not set that, so I'm not going to send it right now to home. In advanced streaming, you can change the buffer size of how many points are in your buffer. And also, here it should give you some information about the buffering status of the points that you're sending to the robot. It is also possible, if we convert this back to a mesh, it is also possible to actually export this as a UR script. So you pick your object, you pick a name for the program, and then if we go into the text editor here, you should have saved a new URP script with your positions. You can copy and paste this into your robot, and this should be it should be possible for you to run this on your robotic arm. If you install the Paramico library in debug Paramico, you should be able to stage that program into your robotic arm, meaning that if you stage it there, right now it's failing, because I need to probably set the correct password here to save that program in the robot, and then run it from the robot itself. So in this case, you can pick the program here again. It should automatically populate after I stage it, and then you can run, pause, and stop the program that is running in the robot. We get some simulation options too, either using the Blender Inverse Kinematic Solver or Newton Inverse Kinematic Solver. In this case, is the Mujoko library. I'm not going to go into that today, but just so you know, in order to run the Newton simulation, you need to successfully install all the Mojuko and Newton libraries from the dependencies. On the info panel again, here's where you can change the home of the robot. You can set different settings to it. Also is beyond today's idea. Now, let's have some fun. So I'm gonna go into the outliner, and I'm gonna enable the rest of my robots here. They should all have popped up. And then on a multi-robot setting, you can see that in the robot registry, when I pick the target of all the different robots, we change the selection of what robot we're working with. So now, in the right and in the left side, there are different brands of robots, universal and you factory, so I can actually, I think they're all connected at the moment, so I'm gonna pick all of them in control, take them into, for example, I could move all the targets of them a little bit. And if I move the targets, if I move my targets and then I click move to target, sorry, you need to select all of them. So let me select all of these and then move to target, and that should take all the selected target robots should update their movement. So you can shift select all the targets and then your move to target should work. In a similar way, we can enable now puppet mode for all of the robots. And that should allow us to synchronously move all the robots. And in a similar manner than we were discussing before, we can add different constraints for each one of these robots. And again, you can play in different ways with the robots, bring them closer or whatever you want to do. And this is the end of this quick intro to the first Animaquina version. Thank you.